ngasi ki topic sidi instantaneous velocity and instantaneous speed haveni paragi yengsi. The average velocity tells us how fast an object has been moving over a given interval of time, but does not tell us how fast it moves at different instants of time during that interval. Mapamadagi mapamada satpada average velocity na swaida kyamyang na tai chatli mapasida swai mapasida amta takte manta ise pull-up sigi average oina takpane badunabo average velocity haini instantaneous velocity sidana kaidorakani hai matamda mapa khudingi exact point mayam sida koina determine tawbu ngamdoine second manga satlakanda mai speed se kya lei tare chatlakanda na kya lei just like sigi wahi sina dum main tawjai je instant tagi lakpani khudak tagi lakpani khudak ki velocity na haidoine sigi se. The velocity at an instant is defined as the limit of the average velocity as the time interval del t becomes infinitesimally small. Sida iri mayamse hairakiyamu atahalaga akoi average velocity v yana tabu matamda sigi x2 minus x1 divided by time 2 minus time 1 hai x2 is in a position at time t2 and x1 is in at time t1 in my position do I give me this gives average velocity p here is my third. See difference in times if this difference in time is very small yeah ado itaragadi instant type idea se lakpi yarni instantaneous velocity is sidagi laktuine when sigi time del t is na 0 da naksan grabha bani yamna taragadi kamain tawge matamda we get instantaneous velocity. Sinai is a limit of del x over del t when del t tends to 0 abni sigi kaiga managi hai matamda dx by dt differentiation na koina tawge bedo adugi duga manaraktoine where the symbol limit del t tends to 0 stands for the operation of taking limit as del t tends to 0 of the quantity on its right side the lazy sigi da del t yaw idana sigi na 0 da naksan kanda tarak do idune everything sina limit low high sigi zu mathematics tamakani sidi class 11 da dum tambani chapter khara sangjal lakanda tamakani sisu then sumaina graph ama leib matamda instantaneous hairak taragadi sima pa sida magi velocity da kamai oibno si sida kamai oibno determine tawba loin yar kido yar toine then chegi examples e lor gi yengsemu hena gyan tana instantaneous ki idea se akoi thaina calculus tawgib da horkda tawgib da adu sinar toine question variance yong. The position of an object moving along x-axis is given by solution da x in a pdc a plus bt square pyramid where a is in a 8.5 meter b is in a 2.5 meter per second square and I unit ka je khenari se kaidongna no hai matamda principle of homogeneity wan bada yarak namni si x se 11 side the lazy mazi meter dani in terms of length ni a should be in terms of length so should bt squared b units in a meter per second square hare times square is second square up ni katha namatamda meter lem hawida adu minor. Then tz is measured in seconds. What is its velocity at time equal to 0 and time equal to 2 seconds? Velocity puto one high velocity di kaino instantaneous velocity oidoini haujikido dx divided by dt velocity katang palama ado itaragadi akoin logdoisi instantaneous velocity ni logani hojiki sidi kaitare d by dt of a plus bt square kanadano differentiate tarok to isa matamda sin dt makha lay sida yengdoini tongan tongan thambi bi are a plus d by dt of bt squared. Differentiation of a constant is 0. Aduna kai tare songi b mapan uthoke d by dt of t square. Sidagi di b laser differentiation pan matamda 2 puthare then 2 minus 1 sinadi kai tare b twice b t na tare. Instantaneous velocity is measured at time equal to 0 habamga time equal to 2 second habamga later at time equal to 0 v equal to kya tage matamda seisida sinjandu ini akoi sinjanda gadi 2b times 0 is 0 meter per second at time equal to 2 second atrama hum give the the velocity equal to 2 times b into 2 cd 4b abni b is value labani 2.5 into 2 4 into 2.5 I do ni with 35 4 is 20 to carry 4 to the 8 9 10 meter per second I'm sure at 2 seconds then question atai desu hangi what is the average velocity between 2 seconds and 4 seconds 4 second 2 second average velocity yung hangi average velocity oita agadi koina taw give the vz average oita agadi x2 minus x1 time 2 minus time 1 f sine block page average item nina at x2 at time 2 ni minus x1 at time 1 ni divided by time 2 minus time 1 is the pyramid is okay no a plus bt square simple hi hoge a plus bt square and so we all are against there again at x2 times in a 4 second amana x2 times in a 2 second x1 2 second do hidai there is the t1 t2 is the layer divided by 4 minus 2 set of times na t level pasida 4 is in the left 6 is the 2 is in the left do it a plus b 4 square laser minus a plus b 2 square divided by what is this 2 sina kai tare ega tanagani 4 is 16b minus 4b divided by 2 ibani 12b divided by 2 is 6b b the kya no to I give the 2.5 6 times 2.5 ibani 6 5 is 30 3 carry 12 13 14 15 si laser 15 meter per second average na swine putokani instantaneous hoigana differentiate simply toraga at exact time karam badano hairagana sigina sinjan biraga loy hojekkido sida su yaure kitang samlap na hotlaga like the yengu adum answer de manana tare tu instant key then average key. Note that for uniform motion, velocity is the same as average velocity in all instances. Uniform motion the velocity is the same as average velocity in all instances. Masa uniform ID hengat pasu lero henda pasu lero iduna mpa ko di makta loina mak mana tabni. hujikiduna instantaneous velocity ni instantaneous speed haitaradi or simply speed haitaradi is the magnitude of velocity gi magnitude to higher lower direction yaura array of c sidadi then I'm going to scalar oire duga velocity haigana vector velocity tawra matung sida khoi acceleration na tawrani acceleration sida yankhalakpa taptharakpa mayam laktuni akhoi aina torokbada acceleration due to gravity ga naga z ga torokbada z 9.8 meter per second square ga naga torokbada acceleration due to gravity ga mathak kai thadarakpada sigi acceleration sida lakani na sina haibidi kaino every second kudingi 9.8 meter per second ze angle a habni second kudingi sigi value ze angle a habni accelerate tawra iyan magi average acceleration gi definition ai targadi yango mazu bar mathak singe average ta ngava v2 minus v1 divided by t2 minus t1 cc del v by del t ni ibayani और इसकी velocity कितना कमाएगी velocity equal to x2 minus x1 divided by t2 minus t1 इवनी acceleration कितना v2 minus v1 divided by time 2 minus time 1 so v2 सिना time 2 तो 1 बा v1 सिना time 1 तो 1 बने so the easy thing v2 and v1 are the instantaneous velocities or simply velocities at time t2 and t1 respectively. It is the average change in velocity per unit time. The SI unit of acceleration is meter per second square. Mathakta meter per second layer, makar second angle layer, punjan matamda meter per second square lakni. Sisu graph tagi aga what pagini so isna kayor kanyeng si then instantaneous acceleration nabam su lairemo instantaneous acceleration sida na kamai taramani average ta yam khenaramani masu limit del t tends to 0 the lerni ozeki del v by del t lebudu when this del t sina yam pikakanda when this del t tends to 0 limit low doini sigi limit low by je aduga kamai tawra dv by dt lakpene this is the instantaneous acceleration sigi graph se kangjan badaka tai dimamangda samana mana dum yarum se or sigi sine position time graph for velocity with positive acceleration je hengalakpagi chum yangalakpagi negative acceleration chum taptharakpagi then sigisina kayara uniform velocity da lagibduni acceleration amta leitrakanda uniform speed or velocity lerakanda lagibdu magloin khangjin dawni then si loira matung di khara maru oi baiba si je maru oi si idea je sin rakani koi paragi engzimo an interesting feature of velocity time graph for any moving object is that the area under the curve represents the displacement over a given time interval velocity time graph ni si in nakanam the velocity laire nakanam the time graph laire moigi area se koi hot taragadi kai lakani am tamda sigi into this natra sigi mathakta layer is y axis the layer is simply velocity then x axis the layer is time ni what gives velocity into time ai taragadi displacement hai sidi tum khangba yare aduna velocity time graph ki area sina kai ta I hai taragadi it gives displacement over the given time interval see time sida displace kyam ta we have do adune man ta toish see velocity time graph se maru way adum sisu yemu hai se e gisna motion in a positive direction with positive acceleration positive direction da positive acceleration leibagi then objeki sigisina positive acceleration ni ko sigisi su acceleration ni positive acceleration ni kamai tawge matamda sidana straight line isi velocity versus time oibagi ni sida khoidisina position versus time oibagi B. The motion in positive direction with negative acceleration. Positive direction di oiba duga speed ti handarakpa. Aduni makada slope where easy. Signa negative direction do aramani ngo. Motion in negative direction with negative acceleration. Motion last the motion of the object with negative acceleration that changes direction at time t1. Sigida positive oirambadagi kamain tawrai. Si hek landang matamda negative oigi natra adani changes direction naise positive sina somnasa targeti negative na opposite om chalam doini ko adumaina lay next ki dadi akhoi kinematic equations for uniformly accelerated motion naise yengse